Alright, and welcome to imaginary numbers. Now, what in the world is an imaginary number? Well, let's take two examples here. Two very easy examples. Here we have the square root of 4, and here we have the square root of negative 4. And let's see. If you were to type these into a calculator, well, of course, the square root of 4 would give you 2, and the square root of negative 4 would give you something like no real solution. Or maybe it would say error. And why is that? Well, the square root's asking what number times itself can get you to 4. Well, we know the answers are 2 times 2. 2 times 2 is 4. And wait a second, there's also negative 2 and negative 2. Negative 2 times negative 2 is positive 4. This is why the square root of 4 is really plus or minus 2. That's where we get two solutions from. However, what about the square root of negative 4? That has a positive and it has a negative 2. Those are not the same. Since they're not the same, we can't take the square root of negative 4. Now, mathematicians actually do not like being told that they can't do something. So, a mathematician, somewhere around the 1700s, improvised the following. The square root of negative 1 is equal to I. And I stands for imaginary. So this is where we're going to get the phrase imaginary numbers. Now, factoring square roots that are negative is something that we can now do. And one side note, imaginary numbers, they are real in the real world. I cannot stress this enough. The word imaginary is a terrible name, but they are real and they are in the real world. Anytime you use your iPhone, the mathematics that creates the circuits is in fact using imaginary numbers. Engines use imaginary numbers, or engineers use them when creating engines. Okay, so let's go ahead and take a look at our very first example. We had the square root of negative 4. The way you do this is you first break it up into the square root of negative 1 and the square root of positive 4. If you will recall, when multiplying square roots, you simply multiply what's on the inside. Well, here we're doing the same thing in reverse. We're just dividing out a negative 1. Now from here, we know 4 breaks down into 2 and 2, or it breaks down into negative 2 and negative 2. So here's what we're going to do. We're going to say that 4 breaks down into plus or minus 2, and the square root of negative 1, remember we said that that was I, plus or minus 2i. The square root of negative 4 is plus or minus 2i. Let's try some more examples. Okay, let's go on to example 2. Here we have the square root of negative 16. Well, what's our very first step? We're going to pull out the negative, and we're going to write the square root of negative 1 and the square root of positive 16. Now remember, we're looking for groups of 2. Well, I know 16 breaks down into 4 and 4. Okay. Or if you'll recall, also negative 4, negative 4. So what's our answer here? Our groups of 2 will be plus or minus 4. And remember, the square root of negative 1 is I. So the square root of negative 16 is plus or minus 4i. Okay, let's break down the square root of negative 50. Well, this breaks down into the square root of negative 1 and the square root of positive 50. Now you'll notice 50 can be broken down into 2 and 25 can be broken down into 5 and 5. Okay, so what are we going to say here? We have our pair of numbers, so we'll equal plus or minus 5. And don't forget the square root of negative 1 is I, but here we have something left over. Remember, this 2 never got circled, so we have to leave the 2 inside the square root due to our basic simplification rules. So the square root of negative 50 is plus or minus 5i square roots of 2. Okay, let's check out example 4, the square root of negative 24. Well, of course, we break it down into the square root of negative 1 and the square root of positive 24. Now 24 breaks down into 4 and 6, 4 breaks down into 2 and 2, 6 breaks down into 2 and 3, and notice we only have one pair of 2's. So when I go to write this, of course, every square root gives us a plus or minus, And this 2, this group of 2's that I circled, gets to escape along with our square root of negative 1, our I value, and we'll have the square root of, wait a second, 2 and 3 stay on the inside. Remember, we put them back together by multiplying. 2 times 3 is 6. So the square root of negative 24 is plus or minus 2I square roots of 6. Okay, let's try our final one for this little page here. We have the square root of negative 60. Alright, that breaks down to the square root of negative 1 and the square root of positive 60. 60 breaks down into 2 and 30 breaks down into 2 and 15. Now remember, 15 also breaks down into 3 and 5. And when I look at this, I see that my only pair is this pair of 2's. So what are we going to say? The square root of negative 60 is plus or minus. We have our pair of 2's that get to escape. And of course, the square root of negative 1 is I square roots of, and wait a second, 3 and 5 have to stay on the inside. 3 times 5 is 15. So the square root of negative 60 is plus or minus 2I square roots of 15. Alright, y'all, I have one final example for y'all. So be sure to come to example number 6, but finish taking all your notes before you move on. Okay, I said one final example, but these are quick, so let's just go ahead and break it down. What about the square root of negative 30? Well, it breaks down as the square root of negative 1 and the square root of 30. We know 30 breaks down into 2 and 15, and like last time, 15 breaks down into 3 and 5. Now here's what y'all are going to notice. There are no groups of 2. There are no pairs of numbers that get to escape. So how do we write this? We say plus or minus, and the square root of negative 1 is I for our imaginary numbers, square roots of, and the 2, 3, and 5 all get multiplied back together, and 2 times 3 times 5 is 30. So when we have a negative number that cannot simplify, we simply pull the I out and just leave the number the same. So with that being said, the square root of negative 11 is simply plus or minus I square roots of 11. It just can't be simplified. Alright, I hope this helps, and I'll catch y'all in our next video.